What are hyperbolic functions? Why do we even call them as hyperbolic functions? And why did we attach trigonometric function for that? What is the relation between sine and sine h? To understand this, we need to understand the series expansions of sine and sine h. We know that the expansion of e power x equals to, this series expansion is given by 1 plus x power 1 by 1 factorial plus x power 2 by 2 factorial plus x power 3 by 3 factorial plus x power 4 by 4 factorial plus till infinity. This is the expansion of e power x. If I substitute minus x in the place of x, e power minus x equals to 1 minus x by 1 factorial. This odd powers becomes negative. 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial plus x power 4 by 4 factorial minus till infinity. So these two are the expansions of e power x and e power minus x. And we also have that the expansion of sine x. The expansion of sine x is given by sine x equals to x power 1 by 1 factorial minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial till infinity. If you take these two functions, e power x and e power minus x, subtracting e power minus x from e power x, I have e power x minus e power minus x. This gives us, so here 1 minus 1 becomes 0 and x by 1 factorial minus of minus. I will write this expansion. 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on, minus of, have 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial and so on. And subtracting these two, I'll get, so 1 minus 1 gets 0, x by 1 factorial minus of minus plus, so it's 2 into x by 1 factorial, x square by 2 factorial and x square by 2 factorial gets cancelled and we'll get 2 into x cube by 3 factorial plus 2 into x power 5 by 5 factorial plus so on to infinity. In this entire expansion, I can take out 2 as my common number. Taking out 2 common, I get e power x minus e power minus x equals to 2 of x by 1 factorial plus x cube by 3 factorial plus x power 5 by 5 factorial plus so on. But if you look at this expansion, it is x by 1 factorial, x cube by 3 factorial, x power 5 by 5 factorial plus so on up to infinity. This resembles the series expansion of sine x. So they are nearly same, except that I have alternative symbols in sine and all are plus symbols in this expansion. So just to assign a name for this, mathematicians thought of giving some name and they assigned some sine function for this. Sine function. So they call it as hyperbolic of sine. But why do we call hyperbolic of sine for this? Similarly, I can find the expansion of cos hx. In hyperbolic functions, we have a relation where it says that cos h square x minus sine h square x equals to 1. If you look at this, it is something like x square minus y square equals to 1. If you plot a graph of this, what we get is an hyperbola. So this equation resembles like a hyperbola. Since my functions of sin hx and cos hx are resembling like hyperbola, mathematicians named this as hyperbolic functions. And instead of writing just sine, they gave the notation as sin h. Sin h. If I plot the graph of x square minus y square equals to 1, what I get is an hyperbola. X power 2 minus y power 2 equals to 1 gives me an hyperbola here. The only equation which satisfies, the only condition which satisfies this equation are cos h square x minus sin h square x equals to 1. In trigonometry, if we have x square plus y square equals to 1, the circle equation, here x equals to sin square theta or sin square theta plus cos square theta equals to 1. So for this, the hyperbolic function of cos h and sin h satisfies this condition. And since they are representing the hyperbola, they are named after that as sin hx, sine of hyperbolic function. So coming back to our expansion here, I should divide this expansion with 2, so it becomes e power x minus x by 2, that equals to x power 1 by 1 factorial plus x power 3 by 3 factorial plus x power 4 by 4, x power 5 by 5 factorial plus x power 7 by 7 factorial, and so on to infinity. This is called as the sin hx expansion, sin hx series. So we're calling it as sin hx because these functions are related to trigonometric and the hyperbolic functions. So they are the combination of hyperbolic and trigonometric. This is called as sin hx. And similarly, if you look at the expansion of cos hx expansion, cos x equals to, this is cos hx, I'm writing the expansion of cos x. Cos x equals to 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial, and so on. If I add e power x and e power minus x, I'll get 1 plus 1, 2, and these two gets cancel out, and these two becomes 2 times of x square by 2 factorial, and these two gets 0, and in that way I can write the expansion. E power x plus e power minus x gives us 2 plus x square by 2 factorial. So this is 2 times of x square by 2 factorial plus 2 times of x power 4 by 4 factorial plus 2 times of x power 6 by 6 factorial, and so on to infinity. Dividing with 2, I'll get e power x plus e power minus x by 2. That gives us 1 plus x square by 2 factorial plus x power 4 by 4 factorial plus x power 6 by 6 factorial till infinity. Cos x series and this series resemble each other except for this alternative signs in cos. So this was named as cos hx, and that is how sin hx equals to e power x minus e power minus x by 2, and cos hx equals to e power x plus e power minus x by 2. Because they almost resemble the trigonometric functions, the name sin is allocated here for this hyperbolic function.